In this video, we're going to see how we can use EIGRP, that stands for Enhanced Interior Gateway Routing Protocol, to perform dynamic routing. In our previous videos, we have already used RIP and OSPF to perform dynamic routing. So the base process would be the same. And as usual, if you want to go into the details and uh, learn about the specifics of how it works, you can easily find the information on internet. And right now, as usual, we are only going to talk about the implementation, and the process will remain the same, that we have to first activate the protocol and then we have to advertise our directly connected networks. Okay, so let's start and go to the enable mode, show IP arrow to get our current routing table, and then we have to go to the global configuration mode and then activate. And then for activating, we have to use the router keyword and then EIGRP and then a question mark. So in OSPF, we have to provide a process ID. In EIGRP, we have to provide an autonomous system number. Okay, and right now, as in OSPF, we are only going to use a single autonomous system number. Okay, so for example, I'm going to use the same 92 here. And now EIGP provides multiple methods to advertise a network, and it can be combination of either RIP, or it can be used as like we did in OSPF. So whichever method you prefer, EIGRP can handle it. Okay, for example, this was the method in which we advertise in RIP. Okay, so if we do that, it can advertise it. Okay, and there you go. So there you go, the advertisement is done. Okay, so right now we are using EIGRP, but we advertise our network like we did in RIP. Okay, so it can do that. It's a hybrid protocol, it can do that. Okay, so show IPRO, and as usual, there won't be any change right now. So let's do the same for B. Enable show IPRO to get a routing table, go to global configuration mode, then activate EIGRP, and I'm going to use the same ID, and for example net, and we can use different methods. For example 20.0 like in RIP, like we did previously, and 30.0, and we can also provide a subnet mask here. Okay, like that. And we can also use a wildcard mask instead of a subnet mask. So 40.0 0.0.0.255, just like we did in OSPF, minus the area ID. Okay, so there you go. So you can also advertise in this way. So whichever method of advertisement you prefer, you can do that. Okay, there is no binding in EIGRP. So let's check which routes were exchanged, and as usual, the 10 was exchanged because right now on the exchanges were between location A and location B. So in B, 10 was missing, and the D, as you can see here, is the with EIGRP. So yeah, there you go. The D stands for EIGRP, so that's why we're seeing a D in our routing table. So it's okay for one. Let's check what other changes were here. So as usual, there should be two routes. Yeah, 30 and 40 from the B, and let's go and configure. So do show IP arrow to get the routing table. Yeah, so activate our routing protocol, EIGRP, and ID. Right now I'm going to use the RIP style, or 40.0, because it's the most easiest for me, I guess, and 50.0 and there you go. Hopefully, yeah, there you go. The 3 routes were exchanged that were missing here from all the other routers. And same way, if we check the B location, it should have the complete 5, yeah, the first 10 and the 50. And for A, the same 30, 40, and 50. Okay, so as you can see, there isn't much difference between the use of different RT protocols. The baseline is the same, just the activation process and the advertisement process can be a bit different. Okay, so that's how you can use EIGRP to provide to perform dynamic routing. And until next time, take care.